Hello you guys, here's your lesson for section 1-5, using formulas in geometry. Missy McCarthy, Okemos High School math instructor. Okay, you're familiar with a lot of what we're going to talk about today. Pretty much all we're going to have is rectangles, squares, triangles, and circles, and we're going to talk about the perimeter and the area for these figures. We'll do a little bit more with this in class, but for now we're just going to focus on the basic formulas and how you use them in a few examples. So here we have a rectangle, a square, and a triangle. So if we're looking at perimeter, perimeter just means distance around, okay? So if we're looking around and they put the congruent marks here because this side and this side are congruent. Oops, I do that every single time. Because this side and this side are congruent, so you can also call that one W. And then you have two tick marks here and two here, so these are congruent, so you can also call that L. So if we're going to find the perimeter or the distance around, we've got W plus L plus L, which ends up being 2W plus 2L. And then the area is the length times the width, so the area is L times W. For the square, it's very similar to the rectangle, except all four sides are congruent, as you can see by the tick marks, and the perimeter in this case would be 4S. And then the area, because both sides are the same, the area would be S squared. S times S, length times width, you get S squared. For a triangle, the perimeter of this particular triangle would be A plus B plus C, and any triangle if you label the three sides A, B, and C. And then the area can be derived by making a triangle half of a rectangle, but is 1/2 the base of the rectangle times the height of the rectangle. Now you can see here that the base B can be any side of the triangle, so it doesn't matter how the triangle is oriented. And then the height is the segment that goes from the vertex and forms a right angle with the line containing the base. So here's one here where if you have the base here, if you go from the vertex perpendicular to the base, or forming a right angle with the line containing the base, it is that side of the triangle. Here, the height is on the inside of the triangle. But sometimes you might have to extend the base out to drop the perpendicular or to drop the line that forms a right angle with the side of the triangle. When you do that, the base is not this entire line. The base is still only this part. That's a big mistake that some students make, and this is still the height. You don't have to include this particular length. That's still the base of the triangle. So let's use our examples to find let's use our formulas to find the perimeter and the area of this figure. So to find the perimeter, again, we have this being 4 and this being 6, but if we use a formula that was 2W plus 2L or 2L plus 2W, we end up with 2 times 4 plus 2 times 6. It really doesn't matter which one you use as L and which one you use as W, because we could take this rectangle and we could rotate it, and then L and W would switch, but the area would remain the same. So this would end up being 8 plus 12, which is 20. And of course, to find the area of this figure, it's length times width, which is 4 times 6, which is 24. Now one thing I should mention is that including units on these is very important. So this would be 20 inches, and because we did inches times inches, this would be 20 inches squared. Here we have x's, so our answer will probably have x's, or will have x's if nothing cancels out. So the perimeter, I have to add all three sides, A plus B plus C, so we get x plus 4 plus 6 plus 5x. If I simplify by combining like terms, I get my perimeter as, let's see, we have x and 5x, that gives us 6x, and then 4 and 6, that gives us 10. So this is as simplified as it can get, and that's my expression for the perimeter. For the area, of a triangle is 1/2 the base of the triangle times the height of the triangle. So we end up with 1/2. The base of the triangle is 6, and the height of the triangle is x plus 4. So again, our result is going to have an x in it. So the area turns out to be 1/2 of 6 is 3, and we've got 3 times x plus 4, or if you use the distributive property, you get 3x plus 12. And again, I should put my units. The units here, because we don't know what the units are, we can just put units. And the area here, we can just put units squared. Sorry to squeeze that in there, but I'm running out of room. Then the last thing we need to look at is the circumference and the area of a circle. Now, circumference of a circle is the same as the perimeter of a shape. So circumference is akin to perimeter. What you can see here is the circumference is the distance around the circle. So they're showing the circumference in a linear format. If you can imagine cutting the circle, let's say right here, and unwrapping it or straightening it out, the distance around will be the circumference. So that's found by pi times the diameter of the circle. The diameter is this distance here. Or, because the radius of the circle is 2 of the diameters, its circumference is equal to 2 pi times r. The area of the circle is pi r squared. So we've got our formulas for circles here. And again, this is nothing new to you guys. You've seen this before. So it says find the circumference and area of a circle with a radius of 8 centimeters. I always still just like to draw my pictures. It's at the radius of 8 centimeters just to clarify and be sure I'm not using the diameter versus the radius in the incorrect way. So I have a circle with the radius of 8 centimeters. So the circumference is going to be 2 pi r, or pi d if you prefer to use that. You just have to double the radius to get 16 for the diameter. So circumference is 2 times pi times 8, and then 2 times 8 would be 16 pi, and then the units, we've got centimeters here, so that would be centimeters. Now here it says use the pi key on your calculator. Don't just use 3.14. Actually use the pi key so you can get a more accurate answer. This would be the exact answer, 16 pi, but you can also use the pi key on your calculator to get an approximate answer in decimals. And it says round to the nearest tenth. To find the area, it's pi times the radius squared. So the area in this case would be pi times 8 squared. And then the exact answer for the area would be 64 pi. And then we would have to do centimeters squared. Now I'm perfectly fine with this answer, but you can also use the pi key on your calculator to get an approximate answer. 64 times pi, you would get a decimal, round to the nearest tenth, and the units are still centimeters squared.